Hello, AP Computer Science. We are going to be taking a look at the answers to some of these recursion problems. Gosh, they can be really hard, hey? That's the thing, when you first start studying recursion, it's a whole new way of thinking. So sometimes you will get stuck on questions, and it'll feel like no matter how much work you put in, like it's just going to not get you anywhere because you haven't quite made that shift in your understanding of what's happening. So it's best to just, try it, and it's really important to try it. You want to give it a shot so that you can sort of understand what you don't get. And then if you get stuck on it, don't spend too much time struggling. Come check out these videos or ask questions in class, okay? So here is count 7. So in count 7, we are supposed to count how many sevens are in a given number, right? So here, for example, 707 has 2 7 digits, right? The hundreds and the ones digit. So it should return 2. And the way we're going to do this requires you to go way back in your memory to like September or October when we learned about integer division and modulus. So that's how we're going to get these numbers. I think I'll just do that as a separate little lesson here, just to make sure everybody understands. If you do, say our number is 707. So here we go, 707. If you divide that by 10, you get 71. You get this part of it. You would expect you to get 71.7, right, if you did that in your calculator, but that's why we have integer division as a separate thing in programming, because sometimes you want to like dissect a number this way. So dividing by 10 gives you sort of like everything. I kind of erased that. It gives you like everything that is left of the rightmost digit. I obliterated the 1 there, but that's sort of what it does. And 707 modulus 10, that's going to give you the rightmost digit. It's going to give you that. In this case, it's a 7. So we can take a look at the rightmost digit and then feed the rest of the number, all the other digits, to the recursive version of the function. Method, sorry, I should say method. So here's the answer of how we go about doing it, and then we'll take a look at the stack trace. Hopefully that'll make it really clear. So here's my base case. If the number is 0, we ain't got no 7s, right? That makes sense because there's no 7s in 0. And we can get that. It's because we can guarantee there is a non-negative number. There is no negative numbers allowed in this question, so 0 is the smallest we can get. So that's that. And then here I'm checking the number's rightmost digit to see if it's a 7. If it is a 7, and I don't even need to have this else, this could just be an if. It doesn't really matter. Anyways, if it's a 7, then I return 1 plus count 7 and divided by 10. And if it's not a 7, I return 0 plus count 7 and divided by 10. So first of all, the 1 or the 0, that's me counting the digit. It's me counting, like, is the rightmost digit a 7 or not? And then this is the recursive call, where I call the method again, but notice that I've shrunk down the data. I'm only sending everything left of the rightmost digit. I'm cutting off the rightmost digit so I don't count it again. So the number is getting smaller and smaller and smaller every time. Eventually it'll get to 0, no matter how big it is. So that's the story. Let's illustrate this now. Hopefully, so far it makes sense, but in case it doesn't, let's go and actually figure this out. Can I erase this? Oh, I can. Okay, so let's take a look at the stack trace for something like count 7, 707. So if we were to do this, the first thing we would do is check the base case. It's not the base case. So then we will see if the rightmost digit is a 7. It is, so it's going to return 1 plus count 7 and divided by 10. So what does that work out to be? This works out to be 1 plus count 7. Sorry, my mouse pen thing didn't work. 71. So we've cut off that 7 because we did n divided by 10. We made the data smaller. And then we just do this all over again. So now this one will return something, right? It'll check the rightmost digit to see if it's a 7. It's not, so it'll return 0 plus count 7, 7. And then count 7 will check the rightmost digit. If it's a 7, it is, so it returns 1 plus count 7, 0, because 7 divided by 10 in integer division is 0. And now this one can finally not be recursive. We finally reached our base case, so that just returns 0. And then we can climb up the stack. It'll collapse the stack. So this will become 0 plus 1 plus 0 plus 1, which works out to be 2. It returns 2. And that's how many 7s are in the number 707. So 717, I guess, actually. So there's the story. That's how that works. I hope that makes sense. Here's one more time to take a look at the code. Make sure it makes sense. If it doesn't make sense, even after you've watched the video, feel not bad about that at all. Just be like, okay, that video didn't get me to understanding it, and try to ask the question in person, either in a flex time or in class time or something soon. Okay. Thanks, everybody. I hope this is going smooth, and I know it's probably not. So keep watching these videos and keep asking questions. Bye, everybody.